Hey everyone, welcome back to Let's Unbound. We are excited to launch a brand new playlist, the FRQ video solution series for the AP Calculus BC 2025 exam. In this series, each video will walk you through one free response question from the BC exam. We will cover solution strategies, graphing methods, technology usage, problem solving techniques. All will be explained clearly and in a student friendly manner to help you succeed in your AP journey. Whether you're actively preparing for the AP Calculus BC exam or simply exploring advanced calculus, this series will be valuable for you. Don't forget to subscribe to our channel and save the playlist so you don't miss any updates. If you have any questions, feedback, or suggestions for what you would like to see next, drop them in the comments. We would love to hear it from you. All right, let's dive into the first FRQ of this exciting series. And it is as same as what question that has been asked in AB. So AB and BC first FRQ is same in 2025. And with calculator, so we are going to use Desmos for this. Let's get started with part A. An invasive species of plants appears in a fruit grove at a time t equal to 0 and begins to spread. The function c defined by c of t equals 7.6 or tan 0.2t. This models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime t equal 38 by 25 plus t square. Your calculator should be in gradient mode. And first question, find the average number of acres affected by the invasive species from time t equal to 0 to time t equal to 4 weeks. Show the setup for your calculation. Let's get started. It's a very simple question. Average value of a function. We know the function, which is c of t is 7.6. It's clearly given there, or tan 0.2t. So when you're writing down the numbers, make sure don't put 0.76. That will make a complete different answers. So coming to this, average value of a function c of t over an interval. Right? We are dealing with this function c of t. This is a straightforward formula we have. A of B is average is what? Sum of all observations by number of observations. So very similar to that. And we have over the interval, we are just looking for 0 to 4, right? So this is actually the formula 1 by V minus A integral A to B. Whichever function you need the average, that will be the integrand and dt. That's it. So here this is your A is 4, A is 0, B is 4, and C of t is given. So 1 by 4 minus 0, integral 0 to 4, 7.6 or tan 0.2t dt. Okay, so it's calculated alone. So we are going to use Desmos to solve this one. Let's get the answer over there. So here is Desmos. Very simple. First give, actually in Desmos, we won't give C of t. We will get some error. So we're going to interpret the variable t as x here. So C of x is 7.6 times arctan. You just type arctan and use the parenthesis 0.2. Don't put t, x. This is my this. And what we need to calculate is average value 1 by 4 minus 0 integral of the C of x and use dx. Okay, so that's what I'm going to do. 1 by 4 minus 0 is 4. And then integral type int. And it's from 0 to 4. So put 0, then go up and put 4 and then C of x. Just type C of x. We already defined it. C of x and dx. That's it. We got our numerical value. So we can take this and interpret our final answer. Here we go. Okay. Hope you might get the same answer whoever solved with me. It's 2.778 when you go for 3 decimal places. So approximately 2.778. And also make sure to give the units for the perfect score. 2.778. What is the function is about? It's about the number of acres affected, right? So acres. That's it. You do this way, you will get the best score, right? And we are moving into the next session. It is find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval 0 to 4. Show the setup for your calculation. Let's get started. Instantaneous range equal to average change. So average change means what will you do? Whichever equals, I'm going to take like this. Average change equal instantaneous change. Okay. But for the same interval, how we will apply find average change? It's just like a slope formula. So it's C of 4 minus C of 0 divided by 4 minus 0, just like a slope. Instantaneous rate of change means you need to differentiate that. Okay. So C dash of t. And we are not instantaneous change, not at a particular point, just overall the time. So we are just writing C dash of t. Okay, we need to find the time t. Yes, we set up an equation here. We are almost there. So we need to solve for it. Again, we can go with calculator. And C dash of t is given in our main description. I hope you might remember this. This is what here. So we can directly use it. And it is 38 by 25 plus t square equals, if this simplifies to what? Right? So we're going to do that in the Desmos. And then, yeah, we will solve it. Completely after this is calculator base. Okay, right. So this is not needed. Actually, we need C of x. So you need C of x because we need to find C of 4 minus C of 0, that stuff, right? That's for that. So this is C of x equal. It shows an error because this dx is there. Okay, so I hope you might remember the left side we want is this fraction. C of 4, like the average rate of change, correct? Minus C of, sorry, C of 0 divided by 4 minus 0. And we got it. It's 1.282. And this is equal to C dash of t. Okay. So let's do that here itself. C prime, I mean prime. When I say dash, I mean prime of x here. So don't confuse with t and x. So C prime x. It's a graph. So where this C 1.282 and this meets. So let me make this as a k or y or something. So where they meet, that is your solution. And this entire stuff you can do here. Now with the reference, I'm going to show it how to interpret the answer. So let's go for this whiteboard back. And this is all we got. Correct? So we solved entirely over here. That's it. So it's 38 by 25 plus t square equal to this 1.282. Or you can directly do like I graphed the left part, I graphed the right part, where the purple and the black curve meets, that is your answer. And clearly my t lies between 0 and 4, so negative is not accepted. This value is accepted. We are looking for t, not for y. So t is approximately 2.154 weeks. We are rounding up to 3 decimal places. Right? This is the answer. Hope you got it. Right. And moving to next question. Assume that the invasive species, wait a second. Assume that the invasive species continues to spread according to the given model for all times t greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. Okay, so for all time t greater than 0, it continues to spread. We need to write a limit expression and that describe the end behavior of the rate of change in the number of acre affected by the species. So very simple. For time t greater than 0, so I'm going to take limit t tends to infinity for any greater time, right? So end behavior of c dash of t. End behavior of the rate of change, not the c of t, okay? End behavior of c prime t. So limit t approaches infinity, c dash of t approaches what? So it's very simple, not a complicated stuff. T tend to infinity, 38 by 25 plus t square. You can even witness that from graph. Like when t approaches infinity, what does function approach? We did a black curve right here. This is the c dash of x. So when t tend to infinity, your c dash of t approaches what? Or we can do it algebraically. So 38 by 25 plus infinity means a very big number. So your denominator is a very big number, and 38 when you divide, it will be approaching 0, right? Now, this is the limit expression and we evaluated it at 0. So what does it describe? Actually, the limit expression is enough, but still, some cases they will ask you to describe or interpret your answer, justify. So what we interpret from this limit t tend to infinity c dash of t 0. Okay, so the rate of spread slows down over the time. Yes, it's spreading, but it's approaching 0. The spread is getting lesser, right? So the rate of spread, it's still spreading, but slowing down. Slow down over a time. That's it. So it's a decreasing rate also we can mention. Now, D part. At time t equal to 4, after the at time t equal to 4 weeks after the invasive species appears in the fruit grove, measures is taken to counter the spread of the species. The function a defined by a of t is equal to c of t minus integral 4 to t 0.1 ln x dx, models the number of acres affected by the species over the time interval 4 to 36 weeks. At what time does A attain its maximum value? Justify your answer. Okay. So from the fourth week, like after 4 weeks, they have started to do some remedies and new function is created now. Again, it's number of acres affected by the species after those measures are taken. Now, when does A attain this maximum value? So after this measure, the amount of acres affected is maximum at some point. So which point? And we need to justify our answer. Let's get started. Like justify the answer means if you got t is equal to 10 or 9 or 36, you have to say why it is your maximum value. That justification we need to give. Okay, so first, what is our aim? Maximize your A on this particular interval. Maximize A on 4 to 36. Right? Maximizing means what? A dash of t is 0. Okay. And A dash of t means what? A of t is given. What is A dash of t? You need to differentiate everywhere. So it is C dash of t. Like integral part, if you differentiate, you will just get the integrand. 0.1 ln x and no dx. Okay, and it seems t, so t makes sense, right? 4 to t, 0.1 ln x. So the anti-differentiation is this, equal to 0. So we got C dash of t equal 0.1 ln t. And C dash of t, we know 38 by 25 plus t square. Okay, let's set it up the equation as simple as possible. Right? So this is what we did so far. And we will get t value from this. We can directly go for calculator. So you can sketch this side, and you can just look at the intersection point. Okay, so now we are moving into Desmos. Okay, so we need c dash of x is equal to, okay, let it be. Another function is y equal to, actually, I don't want this. So, wait a moment. So y is equal to, another curve I need is 0.1 times ln x. Okay, actually this one, okay, so this is the c dash of x and 0.1 ln x. So this is where these intersection is what I need, and here is it is. So we just go through the where they seem to intersect, you can pick that one. So this is my answer, 11.447. So t weeks. Okay, the number of acres is y value. So we should be careful which value we are taking. That's it. So we got it. What is my t? So t is approximately 11.442 weeks. So at that particular, after that much weeks, it's attains a maximum value. But yes, I won't like finalize my answer here because it's we don't know what happened at the endpoints. So if you're working on this interval, so make sure to check on the endpoints too. Okay, right. So here we go. Evaluate critical points and endpoints. It's very important thing. Evaluate critical points and endpoints. So I need to check with A of 4 and then A of 11.442 and then A of, not for A dash of t. A dash of t is just to find critical points. Evaluation will be the original function where we are seeing the maximum value, correct? 36. Let's check this. Again, we need a calculator help. So let's find all these values from calculator. Okay, actually here we need A of x, right? So A of x equals C of x. C of x should be already defined over here. Otherwise, it will show you error. Then integral 4 to x. Okay, that is how it was defined. It's not 0 to x, it's 4 to x. And then 0.1 times ln. Don't use x. Since we have x at the limit, so we have to use t variable here. Okay, I just exactly used the opposite format. So this is my A of x. Let me hide this. And you need A of 4 now. What is A of 4? This one is A of 4. And what is A of that 11 critical point, right? We found it, 11.442. Then the another extreme endpoint, which is A of 36. These are the values we got. Okay. So this is the values. And now we can compare. Clearly, we can see the highest maximum values around 7.31. So critical point is the answer. Here we go. So A of 4 is this much, 5.128. And after after decimal, 3 places, 317, and then 1.743. And yes, clearly we can see the critical point is the max, right? The A of t is also maximum. Yes, candidate test is important. Don't finalize your answer like here. So again, but still we are right. The critical point is where the maximum attains. Okay, let's justify your answer. So why you're telling this? A of t attains its maximum at t equal to 11.442, as why we are telling, as there is a sign change, you can say, because critical point, like critical point is this, and we have critical point means what? So there will be a sign change. So as there's a sign change, and also it's greater than the endpoints. It's greater than the endpoints test that we apply, A of 4 and A of 36. Right. And that's the wrap for this question. So we have break it down in a simpler manner and also with some efficient pointers over here. So, and that's a wrap. If this helped, show some love, like, subscribe, and stay tuned. We have got more AP gold coming your way. Want to prep smarter? Not alone. Join our WhatsApp student community. The link is given in the description. You can chat, ask, and vibe through all with the Let's Unbound family. This is Let's Unbound, and we will catch you in the next one. Keep learning, keep practicing.